Thank you very much for joining this session. I'm Flemming Christensen. I represent a company called Sundance, and I also represent a company called Trends Electronics in Germany. It's not going to be a very technical presentation, so I've been told off already. It's more going to be informative and hopefully give you a chance of learning a little bit more and get some feedback from it. I have a lot of slides, but I will do them quite quickly. Sundance, briefly, is a small little company, and there's about 8 of us. And we run a small operation in Chesham, Buckinghamshire, and we build boards to sort of any applications really, whatever the customers want. Mainly FPGAs. Used to be a lot of DSPs. We don't do any DSP boards anymore. We also work with a number of other companies. They're typically my old customers or partners I work with. They're primarily smaller companies as well. There's a whole list of them, and we have a shop which presents all the products which are available to these partners. Most of them are FPGA based. So Trends is our partner in crime. We use them for our own use as well. So we develop systems where we use them as an OEM customer, and we also sell their products. Trends is a much larger company than what Sundance is, and they have in-house manufacturing facilities and X-ray machines and automations of everything. So I always refer them to a bigger version of Sundance. So the talk here is a little bit about COTS modules, and in my belief that COTS is very useful. And we started with our first COTS module in '93. So it's a little while ago. It had a it was based around a DSP concept. So this module was going next to a TI DSP, and it was an early Xilinx 3995. So it was a pretty old device. So I'm trying to get some feedback here. So how many of you are using sort of systems on modules? Are you users of those? Okay. Not as many as I would like. And hopefully this will help you to convince you that it's actually a sensible idea to use systems on modules. Trends have an incredible line of modules, and some of them which we like very much is in this form factor. It's a 40 millimeter by 50 millimeter module, and we have one of those down in the booth. What's interesting is that everything is available, so that they have a website, and they obviously have a wiki as well. So all information is available now. The important message, and there's a lot of these slides coming through, but it's just to give you an idea of how many modules we actually do, is that the cost part of it. So one of these modules is a fairly large FPGA, Kintex. So we can actually offer that module cheaper than you can buy the chip. And that is part of the reason why it makes sense to use COTS modules. So this is another one, and as I said, I'm going to skip through them quite rapidly. I believe this presentation will be available afterwards, so you can get a feel for it. Again, the level is, and the prices are not always, the price on Trend sites are always available, so you can always find out what they cost. And the level of benefit depends on the popularity of the module. Obviously, if Trends are building 10,000 of these, then the prices will go even lower. So hopefully it's not scaring you off, but they do all flavors of AMDs. And we actually started doing some non-AMDs, which is coming up as well. So the same module standard will actually allow you to add other FPGAs. So this particular one is a microchip prolifier, which is useful because it doesn't take a lot of power, but it's the same form factor. And we do one as well without the SoC, so just a raw FPGA. So the reason why we think they're great and why we use them for a long time is that about probably 10 years ago, we designed some carrier boards for various robotic systems and for some image processing platform. And it gave us the benefit of being able to swap modules around depending on our application. So this particular board is a PC104 form factor, which is an old favorite of mine, and it gives the option for us and the customer to actually take a module and okay, fine, I want a bigger module. Oh no, I need one with commercial temperature range, or I need one with industrial temperature range. So the carrier board will be the same. And if you were designing a system, you could end up buying the smallest FPGA. Or the other way around, you can use the biggest FPGA and then find out you don't actually need such a big FPGA, and you will simply get another module. So another thing of importance for these systems integration is the end of life. So some of you will have no doubt had fun during the COVID of finding components, and so did we. The benefit of what Trends are doing is that everything is transparent. So when they move to a next generation of products, due to some end-of-life issues, they actually give all the information, and it goes on a website, and it's there to make a reference to in the past. And just to give you a flavor, this is one of my favorite modules. It's got a sync multi-core on it, with the one we started with a long time ago. And what obviously happens is that a flash goes obsolete. I mean, it happens. And what Trends will do is then actually give us a note, publish it, and all the customers who are registered who have been using one of their modules before will actually get a notification that Trends now has gone to a different module because of X, Y, Z. And to give you an illustration of that, so the changes to one part number to another part number, fairly obnoxious, but in a critical system, it is not obviously obnoxious. It is very, very important you know what's going on. And they provide information, and it's stored there forever. So the first module was obviously, surprise, 01, and then went to 02, and then another change 03, another change 04, and then another change 05. So Trends will keep the products going, but also make sure that if you suddenly end up with a module in your hand and say, well, what version is that? You can then backtrack because the part number which comes up, you can see that in the red, will actually show you what version you have in your hand. You can go to their website and then backcheck and say, okay, fine, this is the module I have. I need to use this version of the firmware. So to give you an illustration of how successful this particular module standard is, so when this was started, probably 10 years ago, then there was a few modules, but now there's a whole family of them. You can pick more than 40 variations of the same form factor, with the same pinout, with the same functionality, and you can swap them around as you feel like to. So if you suddenly want a faster speed grade because your design needs to run faster, you can get a faster device in the same package and simply just change the module. So another thing which is quite interesting for me is I kind of obviously been selling CUTS module for a long, long time. So who are using CUTS modules then? Anybody using CUTS module? Even less, maybe one. So you're all doing custom designs. Interesting. Or maybe you haven't started design yet, and that's why you're not using CUTS modules. So the reason why I think CUTS modules are absolutely excellent is the combination of if it is provided into an open source format. And CERN started about in 2007 of moving all their designs in. And they use a lot of FPGAs, a lot of very big FPGAs. So everything that CERN will do will, because obviously public funded, so it should really go into open source. They provide everything available. And we then started doing the same because I thought that this was a novel idea. So we started doing that in 21. So this particular module is open source. There's no royalty. You can pick up and you can use it and you can do whatever you like with it. It's just there as a reference, but it's also open source and no royalties. And we got another module which we're going to put into an open source, which is a very, very, very small module, which we have down in the booth as well. It's a 30 by 50 millimeter sort of multi-core sync board. It's a single board computer. And we're going to put that into open source. And Trends does the same, and this is obviously why I love Trends. So Trends have a similar concept, is that everything they've ever done is going into documentation, obviously very good documentation, but also they have a public support forum. So if you have a question about something, you can post it on a public space. You don't have to tell you what you're doing, you can just you can sort of ask questions and hopefully you get the right answer back very, very quickly. But also, you can obviously go and search and find out whether somebody else has had the same question. So that's available for anybody as well. And just recently, like last week, we added another partner to the Sundance sort of brand of selling products, and they do the same. And this is obviously why we work with them now. Is that they have a module, it's a little sync board, and they provide everything available. And this is a particularly successful product because they got more than 13,000 users. Okay, so there's a lot of public information available here. Back to the open source, and there's some other sources. I mean, I'm not going to go through all the slides of all these different companies, but there is available open source and information about FPGAs, which can be very useful. And we go out, and when we go and do a presentation, like one of our guys, he was doing a presentation at IPL as well, and we try to go out and give as much information as we can. So, what I also want to talk about is industry standards. And back in 2008, I was participating in a standard to add add-on modules to FPGAs, and that became something called Vita 57, which has been adopted primarily initially by Xilinx as they were. And the first module they brought up had 2 of these sockets on it. We do not see them as necessarily something which is dedicated to Xilinx FPGAs, because what's happening is some of the other vendors have also added to them as well. But it gives a very easy way of prototyping, but also some of these things go into fairly substantial production. Obviously, what all the FPGA vendors are doing now, they're mainly doing the development boards, and we then end up being sort of custom designing. So this is a custom design FMC module, which will have 16 channels of ADC, and that becomes a standard product. So we end up designing this for a customer, and then we take them and use them afterwards and be able to sell them to other people as well. So Vita 57, it's a good FMC card. Another new one, and it's just ratified last week. It's called Vita 93, and again, it's a mezzanine card which goes on board. So these are kind of some of the attempts to make standardization of modules to have FPGAs on. So my new hobby, as I call it, there's a new concept and a new idea, and it's called Vita 90. They've also called it VNX Plus, and I always hate when they put a plus after something, because what was wrong with the first one? There was nothing wrong with the VNX, but the VNX Plus is now what we're talking about. And what it combines is small form factors. So on the left there's a system where we have them all integrated in it, but they are relatively small, and I can't share too much of the specification because they're not actually ratified, but it is possible, and it has been engineered in a way where you can take various numbers of sub-modules and you can build a baseboard. There's definition of how big things are, so they all become a standard size, and you encapsulate it, and you have a module you can slot in. And they're very, very interesting. So that's one work to have a look at. So what I haven't been involved with, but Trends has, is there's a European consortium called SGET, and they came up probably a year and a half ago, 2 years ago. They came up with, why do we not have a standard for modules? Because obviously Trends been doing modules, and Cluster been doing modules. There are a lot of companies doing some FPGA modules, but they're not compatible. Just making things compatible for Trends with all the modules they have is very, very hard. But they've been trying to come up with this, and it was supposed to be launched, and it's almost here. This is what I've been told. I can only say it's almost here, but it's not been ratified. But it's an attempt to make two different versions of a standard. One is where you have connectors, so physical connectors, and they're sort of primarily done for very very, well, let's say very low, but low volume, but scalable systems. Obviously, it's the same module concept as we have on our module from Trends, but it's a predefined size, and there's a number of them, and all of them are supposed to be compatible by footprint. So the module standard, you can see there's a whole lot of them, but they will have the connectors in the same place, so you can swap between different manufacturers and being able to have sort of a little bit of independence of your vendor. So this is something to follow if you like standardization. And then they also done one of Trends' product, which are coming soon as well, is a module based around this standard, which will have a version 2. I call it version 2. They call it version Gen 2, but I call it version 2. And that's a module which we're going to launch as soon as the chips becomes available. We got more details about that, but you still have to come to talk to me. So the same thing which happened with which is I think is very, very interesting. So it's an attempt to take a very complex FPGA and put it on a PCB. And then have solder balls on it so you can place it like a normal component. So some of you may have requirement for something being ruggedized, and you may not want to have connectors. And I know there's a connector manufacturer around here. He's not going to like this very much, but it's obviously lower cost. Okay, so the cost of the connectors on the other boards. So on these ones, they're high pin, they are very, very fast, and they are quite expensive. So trying to come up with a standard which enables you to be able to change between one generation of one manufacturer is this concept. The name is a little bit difficult to remember, but you see the S and the C at the end. That's what sort of differentiates them. And we have a module coming out very shortly as well, which will have one of these small FPGAs which conform to this form factor. So, as a certain speaker before was running a bit late, and I'm going to give you a bit more time so you can have your coffee. But I just want to summarize why I believe that cuts are a good idea and why open source is a good idea. And it's the redundancy issues, it's the obsolescence issue, and it's the cost. I mean, it is just cost effective to use these modules. And also, if you're going to find a supplier of these kind of modules, you really have to look very carefully to make sure they are providing you with the circuit diagrams. Okay? So all of us will be struggling without having circuit diagrams, but some manufacturers will not offer them, but the people we work with will offer the circuit diagrams. And the technical benefits, well, so when you develop a system, there's so many other things you have to worry about, like carrier boards and firmware and software. And by using some COTS module with FPGAs on it, you can ignore that because you know there's somebody behind you which can support you as well. Commercial benefits, which obviously is very important to the accountants. So because the cost of the modules are very, very similar and sometimes lower than actually the chip themselves, then you don't have to have such a high stock as well. So and there's also the less risk. So if you end up buying too many of them, then obviously it's going to be a problem if you have too many components on it. But you can buy exactly the number of chips you want. Obviously, if you buy larger quantities of our modules, you get a better price, but you can just buy exactly what you require. So that was it. They gave me half an hour, and I said I only needed 20. So I think I used 20, and there's a bit of time for coffee or questions.